and joining us today are Nick and René, doing an AMA on ProxySQL. So I hope I pronounced that right. I think you may even pronounce it as ProxySQL. Maybe that's just a habit of mine. Please jump in and ask questions. Nick has a demo prepared as well. Take it away.
Okay, hi everyone. Let's get started with the topic of this session. So it's basically the topic is ProxySQL and Kubernetes. This is a topic that we chose because, well, deployment options for ProxySQL are important in the community. We get a lot of questions about this, be it how to deploy ProxySQL on premises, how to deploy it in AWS, how to deploy it in GCP. And recently we get more and more questions on how to deploy ProxySQL on Kubernetes. Being Greek, I'd like to just point this out. It's not Kubernetes, it's Kybernetes. That's the actual word. On Kubernetes, we generally have various deployment options, and the goal of this talk is to kind of discuss them, show how you can practically implement ProxySQL and Kubernetes. And well, yes, I hope it's going to be valuable to everyone, and I hope it will fill the gaps that exist, because there's not a lot of material on the internet around this, or there's just bits and pieces. So this is kind of a holistic, I wouldn't call it production ready because every environment is different, but this covers a lot of the bases. So I don't know if there's any questions before we begin, or if I should just go ahead. So I'll wait a little.
I think we have to do a practice on saying Kubernetes again at the end. But it's more a statement than a question. Thank you for that clarification.
All right, so maybe let's jump right into this. Okay, I've chosen the hard path. I've chosen the path where we start with absolutely nothing and build up an infrastructure. The tools I've chosen for this demo are for the virtualization. I'm going to be running Kubernetes in a VM using Minikube. So for the virtualization, I've chosen KVM. Obviously Minikube. We'll also need kubectl so that we can communicate with the Kubernetes cluster, and Helm, which is essentially a helper designed to deploy templates to Kubernetes. So you can have stuff already built. I mean, you can liken this to something like Ansible for servers. You have Helm for Kubernetes. Maybe you're all familiar with the tools, maybe not. If you're not and have some questions at this point or at any point during the call, please just stop and ask. Okay, so essentially, when we deploy this cluster, what we first have to do is install these tools and create the Kubernetes cluster. So I'm gonna just skip ahead and create the Kubernetes cluster in the VM, just with Minikube start. And while this starts up, I'm going to go just briefly through the steps to get to this point. Okay, this assumes you're running on Unix, and these are like quick start instructions. So I'm going to share these nodes. There's detailed installation steps. I'm also including a too long didn't read, just how to get kubectl installed, how to get Minikube installed. It's enough just having the binaries on your machine, so you can just download them, change permissions, and with Helm, run the get Helm script, and you'll have all of these tools installed. Now, once they're installed, the first thing you'll have to do is set up the VM that Minikube will run. I don't have a lot of resources on this server, so I've just given the cluster 8 gigs of memory, 3 CPUs, 30 gigs of RAM, and I've specified that I'm going to be using KVM. So for KVM, I've just installed KVM and libvirt. So at this point, I'm ready to go. I've executed minikube start, and this has created the VM. It's pulling some images that Kubernetes will use for internal services, be it DNS, whatnot. It's quite complex. To be honest, I don't know the intricacies of all of the containers that are used, but minikube takes care of that. So hopefully in a second, this will be running and we'll be ready to go. In addition to the standard minikube installation, what we're going to do is we're also going to add the dashboard. The dashboard is quite nice so that you can have a visual representation of what's going on. You can open it in your browser. Once we enable the dashboard, we can get the URL that it's going to be exposed on. And we can even start up a proxy on an IP address of on our server to forward this. So just to clarify how this is going to work, minikube is going to be running the dashboard. This will be available inside of the VM. But using kubectl proxy, I'm going to expose this on the IP address of the server that's going to be hosting this KVM. So that just simplifies things. It especially helps me because I'm connecting remotely. Typically, you might be doing this in a cloud environment rather than a server of your own. So this will be really helpful here. You'll probably expose some IP that you have access to through a VPN, or you can even take the unsafe route of exposing it directly on the internet. I don't suggest that. In any case, just a word of caution. The IP address you choose here should be safe, especially if you're accepting all hosts. So, okay, minikube is up. It's time to enable the dashboard. So let me just install it. Enable it. It was already enabled because I had it previously enabled. Let's just have a look here. Okay, it's provided me this URL. So now let me start up my proxy. And I can take this URL and go to my server, port 8001. Okay, the gods are with us. So we have the Kubernetes dashboard. Right now you can see it's completely empty. There's nothing to display. We can actually see here the Kubernetes pods. I'm just showing this for the sake of completeness. These are the pods running various containers for the internal Kubernetes stuff, which is out of scope of this call. So let me go back to our default namespace, which is the namespace I'm going to use just for simplicity. Since we're going to be deploying ProxySQL, we'll need a MySQL server. I've chosen the Bitnami Helm charts. These are quite useful. It's very easy to set up your own MySQL cluster. You just add the repo, and you can install the chart with default values or values of your choice. So I've actually downloaded this values.yaml file from the chart, and I've modified a few things. There's a lot in here. I just chose to bump up the buffer pool, the log file size, and just play with the flash log and transaction commit and sync bin log. Within this file, you can also define how many replicas you want. So you can initially start with just one replica. If you want, you can upgrade it, and you can start with as many replicas as you want. Important to note here, when we set the replicas, we can set 3 replicas, and we'll create 3 slaves and connect them to the master. Let me actually just get this installed. So I've installed the chart. As it says here, we need to be patient a bit. The services are going to be exposed here as MySQL 8 and MySQL slave. So these are DNS entries for the service within Kubernetes. And we can see here, okay, the services have been created. The pods are still getting ready because they're using persistent volumes. We have to wait for the persistent volumes to get created, to get bound, to prepare themselves. These are going to be in a failed state for a short while until they come up. No matter, we'll wait. And in the meantime, we'll just continue seeing how this all fits together. So there's a lot of important information here. The most important one is the password. If you're using default, you'll probably, if you're using the default chart, you probably wouldn't have set your password, so you'll need to fetch it here. I've specified this inside of my values. I have the root credential set here. It's good to set it so that you can also use this in your other config files. I'm using root for everything. It's very bad practice, but just for the sake of simplicity, everything will be run with root. So while we wait for this MySQL cluster to start up, okay, we can see the master is up, the slave is still getting ready. Okay, at this point, I'll just go through the deployment options. So for those of you that are familiar with ProxySQL, you probably know that the main options are either to deploy it on your application server, to deploy it in a middle layer, or to use a combination of both and cascade it. So you have ProxySQL installed on your application server, and this ProxySQL instance will connect to your middle layer. Okay, so how is this all represented in a Kubernetes cluster? So deploying ProxySQL on the server is kind of the same as deploying a sidecar to your application. Okay, deploying ProxySQL in the middle layer is kind of the same as creating a replica set with a few pods for high availability that are exposed through a service. So for this demo, I'm going to go through a couple of options. I'm going to start with a layered approach because one of the most natural choices for, and especially for large-scale deployments, is just to put ProxySQL on its own layer. So I'm going to go through deploying ProxySQL on its own layer with standalone configuration, meaning that when I make changes to one ProxySQL instance, they aren't propagated. So I'll actually have to update all of them, and we'll go through how that's done. Then I'm going to extend this and show how you can have a ProxySQL layer deployed, and this deployment is also known as a core and a satellite deployment, if you're familiar with it, where we have one ProxySQL instance that acts as a controller. And this is the instance that we configure. And any configuration changes made to this particular instance will be propagated to the rest, which are not controlled in any other way. We just push configuration changes from the central one. So using this method, you can connect to your controller, make runtime changes, and have those propagated to your whole cluster. Then I'll also go over how to deploy ProxySQL as a sidecar, and end off by combining the approaches and having a cascaded deployment where ProxySQL is deployed in a sidecar as well as a ProxySQL layer. So
I'm curious, just quickly on the core and the satellite. Is the core part of the load balancer as well? Do you use that as like a canary? I like the term. I've not heard it before.
So the way that fits together, it'll be easier to show when I deploy it. But
okay, we can move to it then if you want.
The controller is a separate service to your passive cluster. So your controller service just exposes the admin port, while your ProxySQL, your passive or satellite service, exposes your MySQL backends. It's just for traffic. The one is just for traffic, the other is just for configuration. So this is kind of extending admin and traffic ports through into Kubernetes services. So I'm sure you're all interested to see how this chart is structured. Okay, so I hope you're familiar with Helm charts. If you're not, they're quite easy to use. They're quite intuitive. They're very similar to Kubernetes deployments, but they also provide templating so you can pass a lot of parameters, define variables, and it helps to integrate different services. So the main file is the chart where we just define the API version we're going to use, the app version that we're deploying. Okay, we don't have any other charts. This is quite simple. The files that I've defined will be mounted as config maps. Okay, I've got 3 files. Well, the one is not a config map. This is a script that I'm using for liveness and readiness. It's not ideal, but it's working. It's just something for illustrative purposes. So for the liveness and readiness, I'm connecting to the ProxySQL admin port, and I'm checking that I have at least one instance in my host group 0 where I have writers, because if I have at least one server in host group 0, I know that ProxySQL is up and it's connecting to the backend. So this is ready, it's alive, and it's good to go for MySQL traffic. This will vary from environment to environment, and it will really depend on what you're deploying, because you may have many writer host groups. So it will really depend on how your MySQL architecture is defined. Again, for the sake of simplicity, I'm just going with this simple script. I have a ProxySQL config file that I'm deploying, that will be deployed as a config map. Here, it's a very basic configuration. I've defined my MySQL service endpoints as MySQL servers. I've defined my users. I've defined some basic query rules. These are query rules that we do not recommend for production. It's just for illustrative. It's just a pure read-write split. And I've also defined a replication host group. Okay. Within my templates, as I said, I'm deploying these config maps. And here is the meat of the deployment file itself. I'm using a deployment here, not a stateful set, because this deployment is designed to just use ephemeral storage. We start up the cluster using the config file, and we're not interested in keeping the changes. We're not interested in persisting anything. If a new instance is created or I roll out a new deployment, I expect the pod just to start up using the ProxySQL config file and nothing else. The image I'm using is defined in my values.yaml file. I'll show that in a second. The ports I'm exposing are just MySQL for MySQL traffic 6033 and 6032 for a admin interface. I'm mounting the config maps. I'm defining the liveness probe and the readiness probe. Obviously, these can be different scripts. Again, customization is necessary for these two. And in my values.yaml, I've defined my image to be used. This is coming from a repository of my own. The image is called ProxySQL K8. And the tag is 2010. Another important variable here, which I missed, is the replica count. So here I'm defining how many ProxySQL instances I want behind this ProxySQL cluster service. Let me just talk a bit about this image. This image is based on the ProxySQL official images. This is the recommended approach to use our images. Our images are very minimal. They just have ProxySQL. You might want to add your own helpers maybe your own scripts. So we recommend taking our image, extending it, adding whatever you need. For instance, here I'm adding MySQL client. And the way I do it is I build my image, okay, and push it to my own repository and then reuse that. This is nice because I get it's a way to control the images and not worry so much about stuff that's missing. And it's an easy way to stay updated because you can just rebuild your image using the latest release and still keep all of your customizations. Okay, so it's time to deploy ProxySQL cluster. So I'm going to deploy this with Helm. I'm going to give it a name, ProxySQL cluster, and I'm going to specify the Helm chart directory. At some point, we hope to upload these to the Helm repository, and you'll just be able to get them directly off the web, as we did with the Bitnami. So now that I've deployed that, we see that we have 2 pods that are starting up here. This is also defined as service ProxySQL cluster. We have no persistent volumes. This is just going to create its own volume and use it for the lifetime of the pod. Okay, we can see our pods are up. We can click on our pod. We can check the logs just to make sure everything is good. These are the standard ProxySQL logs you're all used to. Okay, we can see we have our servers up. Their status is good. Okay, and if we want, we can also exec and open a shell inside this pod. The reason that I installed the MySQL client is because it's very useful to do things like this. And I'm connected to the MySQL admin interface. And I can check status of things, update ProxySQL. This is good for troubleshooting stuff, for testing stuff, but if you plan on changing the configuration of your cluster instances, remember that any changes that I will make here will not be propagated. They will only affect the specific pod that I'm configuring. And when I'm connecting to the service, ProxySQL cluster, this is going to load balance between the instances. It's going to send connections to any of the instances that it finds up. So to test things, I would need to connect to the specific endpoint. The recommended way to make a change here would be to edit ProxySQL cluster config map. So I can click proxysql.cnf, go up here. I can, for instance, set the host group to 0. Actually, let me make a less interesting change. I will rename this replication host group HT1, just for illustrative purposes. Okay, now that I've made that change, I can choose to upgrade my cluster. Okay. Now that I've upgraded it, I can go to my config maps. Okay, where it lists all of my configuration, and I can see that change was made to the config map. Although the config map has been changed, the old instances have not taken the change. As you can see here, we have some new ProxySQL instances running. This might, it depends on your environment. Actually, here it detected the change because in my deployment, I've added an annotation that will do a checksum of my config map, and if there are changes, it will redeploy. if I did not have that line in there, my ProxySQL cluster would remain the same, and it would be waiting for me to make the changes. And after making the changes, I would run a command with kubectl. So I would upgrade the chart. No changes would be made, but the config map would be in place, and I could run kubectl rollout restart, and that would go and create new instances for me with a new configuration. So you can have it more automated, you can have it less automated. The choice is yours. It depends on the environment. So all very well. We've got ProxySQL installed, but how do we play around with it? So again, for illustrative purposes, the way I'm going to play around with it is I'm going to connect locally through my server. This is going to be forwarded to the VM, and the VM is going to forward this traffic to the ProxySQL instances. Again, this is not for production. This is just to show how it works. And I'm including steps of how to do it so that, because I think it will be useful if someone's doing a POC to play around with this. So I'm going to enable this Nginx ingress controller, and I'm going to patch the config of the ingress controller to expose my ProxySQL cluster service and port 6033. Once that is done, I can verify that it's done correctly. Okay, I can see 6033 has been bound, and now I would like to essentially reverse proxy this to my host port. Host port is a local port on my server. So I've created this ingress controller patch, and I'm going to patch the deployment. I'm going to patch the deployment. And the deployment is patched, as you can see. This is the same file I have here, and it's just mapping that port to my host port. So now, using my Minikube IP, which is the IP of the VM. Oops. Just takes a little while for that change to be persisted, because again, the ingress controller needs to be recreated. So I connected to my MySQL database, and this is through ProxySQL. I'm going through either one of the two instances. I don't know which one. I don't care. I'm connected. So I have a sysbench test here, which I'm going to run. The first time I'm going to run it, I'm going to run it without ignoring errors. The reason is I want to show what would happen to an application that's connecting to this ProxySQL cluster, and how it would respond to some error. Okay, so I'll run sysbench test. Okay, it's connected, it's created 10 tables, it's inserted some data, it's creating some indexes, and we've started processing transactions. Okay, so I've got some things going through there. For the sake of completeness, I'm going to open up a shell here. 46032. Process list. Okay, I can see there's some stuff going through here. Okay, all very well. So it's running. My pods are up. Ooh. Okay. So I can go into my replica set, and let's delete one of these pods. This is an example of how an application would respond, how an application that's using persistent connections would respond. Because it's established the connection and it's holding onto this connection, when I do this restart, when Kubernetes creates a new pod and destroys the old, that connection is not going to switch over. That connection is going to die, and so is sysbench. This process is going to report errors and drop any second now. And there we go. This was expected. I'm pointing this out because it's important when you're designing your applications and you're designing your infrastructure to consider these issues. Now, I'm adding the option to ignore errors, and I'm going to rerun this. This is an example of an application that either, well, I'm more trying to illustrate what would happen if you're retrying your connections or using non-persistent connections. You'll lose some connections, but it's not that bad. It's actually a very small glitch. For some applications, it might be acceptable. We'll notice this in the error rate. I think it might have even been that. And this was a really fast switch. Okay, it seems all pods are still up. Okay. It's a small glitch. I mean, it's not even reporting on the number of errors per second. So this is a consideration when you're deploying ProxySQL as a middle tier. I want to stop for a minute if there's any questions, and if not, I'm going to go into the other deployment methods. Any questions? Okay, so let's stop this sysbench test, and let's get rid of what we created because we're not happy with its implementation. This doesn't fit our needs, so I'll just delete the ProxySQL cluster. My service should be already gone. Yep, the service is gone. The pods will be gone. Kubernetes will clean them up soon. In any case, for all intents and purposes, that has left our cluster. So now I'm going to move on to the deployment of deploying ProxySQL in a similar way as a layer, but with a controller sending the updates to the rest of the instances so that I don't have to roll out updates and bring down my ProxySQL instances. I can keep them running. They're uninterrupted. They'll take the updates from the controller, and any changes I make, I can either make directly using the CLI to my controller, or I could even recreate my controller. An important difference in how a controller is deployed is the fact that I'm not using a deployment, but I'm using a stateful set. This is in order to persist the database, because we want that in the controller. We want it to persist across restarts. We want this to be a more permanent pod. This is kind of, we can even kind of call it static. It's very similar. The key difference is that I only expose the 6032 container port. And although I've designed it as a stateful set, you can create a lot of controllers behind this controller service, but it's recommended just to have one, so that this can be the single point of truth. And at the end of the day, if your controller is down, your ProxySQL service is not down, because the satellite nodes continue serving traffic. They just won't receive any configuration changes, so you can't configure them while your controller is down, and you can't spawn new passive instances. So let's go ahead and deploy this. Before I deploy it, I also would like to show another difference. in the ProxySQL configuration, I've configured a scheduler. This is a scheduler that runs every 5 seconds. And every 5 seconds, this script will run a checksum, see if it's different. If it's different for any reason, or if it hasn't been loaded, this SQL will be run. The reason I'm using this approach is that the satellite nodes are going to be communicating with ProxySQL through ProxySQL cluster. When you're loading configuration from the config, you're at version 1. You want the version to be newer than version 1 so that these changes are propagated. So this is just for simplicity, and also because when you're configuring your controller through the CLI, you're going to be running SQL commands. So you'll make some changes. Once you're happy with the changes, you can load, you can save to disk. So this will be saved to disk. It will be on the persistent storage, but as an extra level of precaution, you'll want to update your config map so that you can have these in case for some reason you delete your volume accidentally. Another option is not to use a config map for this file, but rather to mount it on a volume. So you can edit this file, and once it picks up on the changes, it'll update it. So you can have just one place to edit that file. Okay, so let's deploy this and see how it looks. So I'm giving it a name. This can be any name of your choice. Again. Okay. Let's give it a while, just as with the MySQL pods that use persistent volumes. We have to wait a little while for the persistent volume. This is another reason not to use a persistent volume. It takes a while for the pod to initialize. Not a big reason not to use them, but just something to consider. And if we have a look at the logs, we can see that this instance has started up. Okay, it's connected to its instances. Okay, we can see here, save MySQL service to disk, save them. We can see that the scheduler has executed the script. Okay, and here we're seeing this warning because I have ProxySQL servers configured and it's referencing itself. So this is safe to ignore. This is just the ProxySQL servers address that the satellite nodes will connect to. If we look at the satellite node configuration, all I'm defining in the ProxySQL configuration file, apart from my admin and my MySQL variables, is ProxySQL servers. I have no MySQL servers, no query rules. I just have the bare essential information for this passive instance to start up, connect to the controller, and put its configuration. And for an extra safeguard, you can also set the admin interface to read-only. That will prevent any changes being made to a passive instance. So I'll install. And one more point. In my values, again, I can define the replica count, just as with the regular ProxySQL cluster. So you define your replica count here in the deployment for the satellite instance. I'll install ProxySQL cluster passive. Again, it's just the name. And now I'm specifying the helm chart. Okay, so let's have a look at these pods. Okay, I can see this instance is up. It came up very quickly. If I click on it and I check the logs, you can see that it started up, fetching MySQL query rules, loading runtime, saving to disk, performs all of the updates that were on that were executed on the controller node, and this instance is now, this service is now ready for action. we can see that service here. We have ProxySQL cluster passive, and I can run a similar sysbench test and connect to this, and as you can imagine, it will behave similarly to ProxySQL cluster. The key difference is that in this deployment, whenever I want to configure ProxySQL in runtime, I can go directly here to the ProxySQL cluster controller. Just give it a second. And I can also open a shell through command line, but I really like this web user interface. It feels great. Copy paste doesn't work very well, but it's useful just to quickly get to your server. So let's start from MySQL servers. Update MySQL servers. The comment equal to now if I go to the passive instance, I can see in the logs that it detected another change and it's taken the comments from the controller node. So really fast updates. It's really fast to start up these passive instances. That's really good when you want to scale quickly because I mean, this is the power of Kubernetes, right? Scaling and auto-scaling. So I mean, if I want to scale now, I can just say 4 instances and hope that my server is not going to crash because it doesn't have a lot of resources. But we will see here that these instances come up very quickly, and they're ready to go with the configuration that I have on my controller. Okay, I see we're slowly running out of time, so I'm going to try and speed things up.
Just a comment while you're speeding things up as well. We receive reports the comments section isn't working for everybody, so just a reminder, please interrupt Nick if you have a question. I'm sure he'd be happy to take it.
Okay.
Yeah, so if you want to confirm that someone else may actually have access to the comments, it's not entirely clear to us if it's only us who are able to comment or if others are as well.
If it's some strange Google Meet setting that we're not aware of, I looked through the settings. I'm sorry, I couldn't find it.
Okay.
Oh, there's René.
Okay. So
Thanks, guys.
I'm going to scale this back down to 2 because I don't have a heck of a lot of resources available. So this is going to drop back down to 2. At this point, because I have my passive instances running, I could even delete my controller. It's irrelevant. I'll still have services available. I'm going to try, because there's only 10 minutes, I'm going to merge these 2. I'll go through deploying ProxySQL as a sidecar. I'll just look at the deployment and then go straight ahead to deploying a cascaded ProxySQL instance. So if we look at the sidecar chart, it's very similar to ProxySQL cluster. I've included all of the files that are in ProxySQL cluster. The key difference is that I need to define ProxySQL within the application's deployment definition. So here, thanks to my friends at Several Nines for this really cool image that has sysbench in it that I'm using. Props to whoever made that. This is what I'm using as an application for this deployment. So we have the Several Nines sysbench image with some parameters here. And I also have a ProxySQL container defined. So I've got two containers defined within a single pod. The configuration is largely the same for ProxySQL. The key difference is that here I have my application not connecting to a service, it's connecting to the local host, and it's connecting to the port 6033 where ProxySQL is bound. the ProxySQL configuration in this case is pointing to MySQL services. Okay, so straightforward, easy way to deploy ProxySQL as a sidecar. And if I deployed this, I would have the ProxySQL instances connecting directly to the database. Instead, I'm going to go ahead and deploy this cascaded chart. Again, it's similar to the ProxySQL sidecar. The key difference is that here, the address I'm using is the ProxySQL cluster service. So I have a pod with the application container, which connects to the ProxySQL container. This in turn connects to the ProxySQL cluster service, which will send to one of many ProxySQL cluster instances that will forward the traffic back to the database. A question maybe, why are we doing this? Why would you want both sidecar as well as a central layer? Well, that goes to the original discussion we're having at the start of the call, where if your application has persistent connections, these persistent connections will stay persistent between the application and the ProxySQL sidecar, where your ProxySQL instance in the sidecar will live as long as your application. So that's quite safe. And if you lose that ProxySQL cluster, your pod will become unhealthy and a new one will be created. So with this configuration, in case you lose one of the instances behind your ProxySQL cluster passive service, the backend connections might drop from the sidecar's ProxySQL to the central layer, but it will retry them. For sure, if you have a transaction open, it will still roll back in this case, but that's the reason we use transactions. We want them to roll back. We want to handle them, so your application will have handling. But for regular statements, just SQL statements running outside of transactions or simple stuff, it will just get retried. So let's go ahead and deploy this. Have a quick look at how this will look in Kubernetes. Now, I also want to mention a pain point with the sidecar approach. If we look at the template definition, within the container section, we just list two containers. Even though I'm listing, even though the order of your containers is irrelevant, Kubernetes will create these in parallel. So there's a race condition. Your application might start up before ProxySQL is started up. There's no nice way of addressing this. There are some workarounds with an init container that will go and instantiate ProxySQL. But at the end of the day, this is just something that's innate, and you should consider and build for this. So perhaps add a sleep, try and synchronize things, add a check in your application to make sure that the ProxySQL service is available before trying to connect to it, so you don't have unnecessary failures. Okay, so let's have a look. Okay, this was quite successful from the looks of it. This was created. If we go to the logs, now the logs I'm seeing here are the logs from the first container that's defined. Okay, here we go. There we see it. Suspension is running, and if I connect, let me just make sure this is a healthy pod. If I connect to my passive, I could see I have traffic going through. So here we're connecting through the sidecar. We can also connect to the sidecar and show the process list. You can continue to diagnose ProxySQL as you would on a VM or a bare metal server. It's very versatile, and I think to end off this call, we should do something dramatic, perhaps scale this deployment up. But on a more serious note, if anyone has questions, I've pretty much shown all I had to show for.
That's great. Thanks for the demo. So, Nick, what we might do is see if we have any questions with the video on, and then if you don't mind hanging around for a few minutes after, I'll give a private opportunity to answer questions as well.
Sure, no problem.
So, open for questions. Any softballs? Please go ahead.
I guess Kubernetes is still a little bit intimidating to a lot of folks. How you actually pronounce that, Nick?
Kubernetes.
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 Yeah. There is a question in the chat for you as well, Nick.
Oh, this is a question that I think René can answer. René?
Sure. So basically the question is, what is the level of support for AWS RDS, either MySQL or MariaDB, and similar for GCP Cloud SQL? Well, ProxySQL in general can run with any backend topology, so it doesn't really matter if you are running on a VM or any other hardware where MySQL is running directly, or if you are using AWS RDS with either MySQL or MariaDB. So same things apply for GCP Cloud SQL. So yes, ProxySQL will be able to run on top of all of them. And then, of course, you can have different replication topology, and ProxySQL should handle the majority of them. So it supports the standard replication, group replication, Galera, and so on. And also support Aurora if you are interested in AWS Aurora. So yes, it supports all of them.
And it's just important to point out that there's extended support for certain additions like Aurora, Galera, group replication, with more specific checks for those implementations.
Excellent. Well, thank you, Nick, for joining us, and thank you, René, for the questions. I'm going to turn the video off now, but please stay on the line. If you have any additional questions, feel free to ask.
Okay, thanks, Morgan, for having us. And Liz. Thanks.
Thank you, guys.
Thank you.